Hello everyone, welcome you all in the Azilite exam prep channel. Don't forget to subscribe our channel and hit the bell icon so that you get latest update. So without further delay, let's get started. So today we are going to discuss about valence bond theory. So let us learn the super easy concept of valence bond theory through various examples. So firstly, let me teach you what are orbitals. So consider hydrogen atom. We know that every hydrogen atom has only one electron and it is constantly revolving around the nucleus. If I ask you where it is revolving, I hope you all know the answers. So electron is either revolving in x direction, either revolving in y direction or in z direction. So one can say that electron of hydrogen is present in three-dimensional region. It means spherical region. So around the nucleus. So now listen very carefully. The 3D space around the nucleus atom where we can spot electron are called orbital. So therefore we define orbital as the three-dimensional space around the nucleus where the probability of finding electron, it means the probability of spotting electron, finding electron is maximum, where the probability of finding electron is maximum. So that is known as orbitals. For example, if I ask you the shape of s orbitals, the shape of p orbitals and the shape of d orbitals. So the shape of s orbital is spherical, the shape of p orbital is dumbbell shape and the shape of d orbital is dumbbell shape. So now let us consider the hydrogen atom. This is one hydrogen atom. You know that one hydrogen atom have only one electron. Let us consider another hydrogen atom which is also a one electron. And these two hydrogen atoms combine together and these two hydrogen atoms react with each other to form a hydrogen molecule which is H2 molecule. And now here is the interesting part of the lecture. Have you ever wondered and are you ever asked to your teacher how the orbitals of hydrogen atom combine together to form hydrogen molecule? Well, let us learn about the big boss. Big boss means to say B boss. B means this B stands for bond length. B boss. This B stands for bond length. This B stands for bond energy. And this oxygen O atoms stand for orbital overlapping. And this S stands for shape of molecule. It means BBT theory simple. It learns about the bond length, bond energy, shape of molecules and the orbital combinations is there. So remember that this is my personal mnemonic. Big boss means B boss about BBT theory which you can never find anywhere. So if I ask you what is BBT means valence bond theory. So valence bond theory, the answer is very simple. This theory teaches B boss. B boss means to say bond length, bond energy, shape of molecule and O for orbital overlapping. So can you answer all these questions? What is bond energy, bond length, shape of molecules and orbital overlapping? So note it down. Valence bond theory also explain only covalent bond, not ionic and metallic bond. It means BBT theory basically give importance for covalent bond. So let us know the postulates of valence bond theory. The first postulates of valence bond theory is based on the formation of covalent bond. Covalent means the formation of overlapping of two atomic orbital. It means first postulates tells about the formation of covalent bond. For example, if there is a hydrogen atom and there is a chlorine atom, hydrogen atom, the valence orbital is s orbital and the valence orbital of chlorine is p orbital. They overlap each other to form in this way, one atom of hydrogen and one atom of chlorine. These overlapping region, note it down, these overlapping region, this is a overlapping region and which have a maximum density of electron. So first postulate explain the formation of covalent bond. So let us talk about second postulates of valence bond theory. So second postulates explain the types of orbitals. Only half-filled orbitals overlap to form a covalent bond. Note it down, only half-filled orbitals overlap to form covalent bond. Let us consider this s orbital. Here is a paired electrons and this is another orbital which is a p orbital. This is unpaired, so there is no covalent bond formation because the second postulates of BBT theory explain the half-filled orbital which are overlap and there is a none of any case of overlapping. So third postulates of valence bond theory explain the spin of electron. It means the spin must be opposite in overlapping orbitals. This is a p 2p orbital and this is a 1s orbital. This is upward direction, this is in downward direction. It means there is a overlapping takes place. If I ask you in this way, this is a p orbital upward direction and s which is both paired as well as unpaired, there is a upward and downward orbital. So there is nothing any case of overlapping, no overlapping is there. It means no covalent bond is formed. So third postulates talk about the spin of orbitals. If I ask you the fourth postulates of valence bond theory, it identify the orbitals, which means that the orbitals retain their identity after overlapping. It means once it overlaps, it also retains their identity. It means consider the hydrogen atom. As you know, this is only one electron is there and there is a p orbital which is in a downward direction electrons and which is dumbbell in shape, and when these two orbitals are combined together, then there is one is a spherical region and one is a dumbbell region and there is a 2 electron, which means this is a structure of HCl hydrogen, this is a hydrogen, this is a chlorine, p orbital of chlorine and this is a s orbital of hydrogen. So remember that the energy of atomic orbital, higher energy before overlapping and after there is a low energy. It means before overlapping there is a high energy of our atomic orbitals. If it's overlap and their energy is low down, means slow down. So fourth postulates talk about the identity of orbital. It means orbital retain their identity after they overlaps. So move to the next one. So fifth orbital of BBT theory explain the number of bonds. How many numbers of bonds are there? If there is a one unpaired electron, there is only one bond. If there is a two unpaired electron, it means there is a double bond. And if there is a three unpaired electron, there is a triple bond. For example, in case of nitrogen, as you know, nitrogen in this way you can draw, and here is a NH3. It means one hydrogen atom. To form NH3, it means ammonia. Due to three unpaired electron of a nitrogen, it means there is a three bonds are formed. So fifth postulates of valence bond theory explains the number of bonds. So sixth postulates of valence bond theory explain the bond energy. and bond length. Bond energy and bond length. If I talk about bond energy and bond length, the extent, the limit of overlapping decide the bond length and bond strength and bond energy. It means to say the extent, the limit of overlapping decided all these two terms, bond energy and bond length. If there is a overlapping, larger overlapping, it means there is a larger bond strength, bond length. If there is a minimum overlapping, then there is a smaller bond energy. Maximum overlapping decided the larger bond energy, and there is a minimum overlapping decided the smaller bond energy. Let's just understand this with the help of example. If there is a p orbital and which are overlap in this way, it means there is a minimum overlapping. There is a minimum overlapping, and it means smaller bond energy. If there is a p orbitals, both p orbital are arranged in this way, these two orbital close to each other, it means there is a maximum overlapping. Here the overlapping is maximum, it means bond energy is high and the bond length is smaller. The concept of bond length, which is inversely proportional, it means bond length is smaller. So valence bond theory explain the sigma and also pi bond. Sigma bond and there is a pi bond. Sigma bond means there is a axial overlapping. Axial overlapping, it means head to head overlapping. Head to head overlapping, it means in this way. Two p orbitals are overlap, and if there is a pi bonding, pi bonds is formed, it means there is a parallel overlapping. It means parallel overlapping, side to side overlapping. It means one or these two orbital are arranged in this way. So these form pi bond. So thus valence bond theory introduced the concept of sigma and pi bonds. So let us summarize all these concepts. So first is valence bond theory. According to this valence bond theory, the electron in a molecules occupy only atomic orbital. It means we have to focus more on atomic orbital rather than molecular orbital. If I talk about MOT, molecular orbital theory, which we talked earlier, so that is a MOT, molecular orbital theory, but here we talk about only valence bond theory, which is only focus on atomic orbitals, and these atomic orbital overlap on the bond formation. As you know, the bond formation is covalent bond, larger the overlapping. So the first application of valence bond theory is it explains the covalent bond in a several molecule. It means there is a formation, it means maximum overlapping condition is there, then the formation of covalent bond in a several molecules. As you know that covalent bond is formed by the mutual sharing of electron between the combining atoms of same and different atoms. It means there is a same atom, it means hydrogen atom combined together to form H2 molecule, and there is a hydrogen atom and chlorine atom combined together to form HCl. So covalent bond is a mutual sharing of electron, either there is a same atoms or there is a different atom. So first application of valence bond theory, it explains the formation of covalent bond. So let's explain the second application of valence bond theory, which is very important. There is a difference of length and strength of chemical bond, which is H2 and F2 molecule. It is explained the difference in overlapping. There is an extent of overlapping which is maximum or a smaller, which we discussed earlier. So the third application of valence bond theory, the covalent bond in hydrogen and fluorine molecule, HF molecule. So there is a 1s orbital of hydrogen and there is a 2p orbital of a fluorine, which is explained by the valence bond theory. There is a covalent bond between H and F molecule. So let us explain the limitations, the shortcomings, the drawbacks of valence bond theory. The shortcoming of valence bond theory, the first shortcoming is it cannot explain the tetravalency exhibited by the carbon atom. By the carbon atom exhibit tetravalent and there is a tetravalency in the carbon atom, it cannot explain. And the second limitation is it cannot explain the energies of electron, it means inside offered energies of electron. And the third one is it cannot explain the localized in a specific area, where the electron it only assumes the electron which are localized in specific areas, particular areas. And the fourth one is it does not give the quantitative interpretations, analysis of thermodynamic and kinetic stability of coordination compounds. Coordination means to say complex compounds. So it does not explain the weak and strong ligands. This is a concept of coordination compound where the central metal atom which is surrounded by the ligands, the central atom which is surrounded by the ligand which are strong or weak, it does not explain. And the final is it does not explain the color exhibited by the complex compound and coordination compound, because the colors of a coordination compound is due to DD transition. It does not explain by the valence bond theory. So this is all about. Thank you for watching.